In Chapter 5, we introduced the binomial distribution. It was a discrete distribution and it had a special name because we see it come up often. Chapter 6, we talk about continuous distributions, and we introduced some specially named continuous distributions. The first one is the uniform distribution. It's pretty simple to work with, and I'm going to show you how to do the calculations quickly with this example. Pause the video, read through the problem description. Our random variable of interest, we're measuring the amount of gasoline sold daily. This follows a uniform distribution. X follows a uniform distribution. U is for uniform. What's unique for the uniform distribution, when we notate it, we say X follows a uniform distribution, A is the minimum, and then B is the maximum. That's what goes into parentheses. So in this case, my minimum is 2,000 gallons. The maximum is 5,000. Uniform distribution we can write as a geometrical shape. It looks like a rectangle with a minimum at 2,000, a maximum at 5,000. The height of my curve, even though it's just kind of a straight line, that's supposed to be a straight line, is 1 over b minus a, or in this case 1 over 5,000 minus 2,000. Let's take a look at A. Find the probability daily sales fall between 2,500 and 3,000 gallons. Finding the probability that X falls between 2,500 and 3,000. This is a continuous distribution, so whether or not I have equality signs there makes no difference. Refer to these properties of a continuous distribution to further understand that. To calculate this probability, we use the fact that the uniform distribution is kind of a rectangle shape. We just calculate probabilities using basic geometry rules. So between 2,500 and 3,000. I'm going to re-sketch this picture down here just so I can see what I'm calculating. Okay, and the height is at 1 over b minus a, or 1 over 3,000. So I want the probability, or the area under this curve, right? Areas under curves are probabilities between 2,500 and 3,000. So I need to calculate this area. That's the probability that X falls between 2,500 and 3,000. To do that, I just use this basic geometry property to calculate areas of a rectangle. Base times height. The base is 3,000 minus 2,500. The height is the 1 over 3,000 equals 0.1667. Okay, let's continue. What's the probability the service station will sell at least 4,000? What's the probability that the amount of gasoline we sell is at least 4,000? Again, I can have the equals there. It does not make a difference. This is a continuous probability distribution. Okay, so I want the probability, or the area under the curve that's past 4,000. So I want to calculate this shaded rectangle here. I'm doing the same thing, base times height. Now my base is the length, the difference between 5,000 and 4,000, times the height. 0.3333. Part C, what's the probability the station will sell exactly 2,500 gallons? Probability that X equals 2,500 is 0. This is a continuous distribution. We can only calculate probabilities for ranges of values. So kind of a trick question. Again, look to these properties and formulas for further understanding about that for a continuous distribution. Service station manager labels any day that is in the bottom 20% of sales as a bad day. Let's always start with a picture. It just makes our job of calculating something so much easier. So whenever we're in the bottom 20% of sales, so when we sell, this is the amount of gasoline we sell, whenever we're in the bottom 20%, that's considered a bad day. So whenever we sell less than this K value, we're in the 20%. So this is the same concept of base times height. We're just solving for something else. This time we're given a probability. We know that base times height equals a probability, and typically we're finding the probability. Here we're given the probability of 0.2. And I need to fill in the rest of the pieces. My height is still the 1 over 3,000. The base is the length of this 20% piece, K minus 2,000. From here, then, it's just algebra to solve for K. We want to find the K value that makes this equation true. Multiply both sides by 3,000, add 2,000 to both sides, K equals 2,600. So anytime we sell less than 2,600 gallons, we're in the bottom 20% of sales, that's considered a bad day. Calculate the mean and variance of the amount of gasoline sold daily. All these different distributions have different formulas to calculate the mean and the variance. Above on this worksheet, I gave you those formulas, so go ahead and look at those before continuing through this. To calculate the mean, though, it's the minimum plus the maximum divided by 2. 2,000 plus 5,000 divided by 2. Or on average, daily we sell 3,500 gallons. The variance is a little different formula. It's my maximum minus the minimum squared divided by 12. Always 12. That's just part of the formula. Equals 750,000. This would be gallon squared. Not very interpretable. So let's change the variance into the standard deviation so it's easier to interpret. So we're just going to simply take the square root of my variance. Square root 866.0254 gallons.